Thank you very much. So thanks for attending. Thanks for being here. I'm here to talk about secrets of building robust UI components. I want to try something, actually. I haven't rehearsed that. It was just my idea just 4 or 5 minutes ago. I want to try something with you, like really quickly for 1 minute. If I raise this hand, can you, on this side, say just like a quick O? Can you try that? OK. And this side, La. OK. OK, something else. You say, when I do it first, you say O, and then you say way, OK? And then when I do this one first, you say La, and then you say web, OK? Got it? OK. Once again. Hola. Cool, thank you. She already mentioned, I'm so often here, but it's probably time to learn some Espanol, actually. So if you have some recommendations for me, I'm happy to learn about it for Spanish lessons or something like that. So maybe a little bit about me before we start. My name is Glenn Reyes. I'm an independent software engineer based in Vienna, Austria. I do React, GraphQL, design systems, and TypeScript for a living. And I'm planning actually to post more React tips and tricks, patterns soon. So feel free to follow me on Twitter. I'm Glenn Reyes, but without the E's. So make sure not to miss them. Now, let's talk about building UIs. So personally, I've always found building UIs a super positive and challenging task to do. So for me, building UIs is like super fun and enjoyable to work on. But at the same time, building robust UIs is quite hard. So it's similar to things where I'm like, oh, I want to create this app, I want to create that app. Maybe I want to create a video, or I want to create maybe a song, everything that I like. So it's so beautiful, everything. But once you are forced to give more thoughts and effort into something, like not just making UIs, but giving like thoughtful, robust, then there's a bunch of challenging stuff to think of. So maybe let's take a step back and begin with the definition of robust. So what is robust? So I thought, why not ask ChatGPT and let that answer for us? So here is how it responded. So it's quite a long text. I thought it was a little too long, so you don't have to read all of it now. But I highlighted the key things out of this paragraph that I found important for us. So in this slide, put it all together. So what makes user interfaces robust are things like reliability, stability, and both under a wider range of different conditions, and consistency of user experience and performance. So building new user interfaces come with certain foundations. To me, I think what makes me feel real comfortable and productive to start building UIs is by getting the right tools in place, the theming and the design system specified, and the key strategies and approaches of actually building them. Let's talk a bit about tooling first. So before we start building something, we need tools, right? And we don't only need like just any tools, but we need good tools. And ideally, the best tools. The better the tools are, the better the developer experience are. And therefore, better quality output we get. Better tooling helps us move faster and with the most reliability possible. And we not only need tooling to help keep our code base clean, but also keep our code base clean without much work from us developers required. So anything that can be automated or auto-fixed without us requiring to do anything are such like foundational things to help us achieve building more robust interfaces. So super basic things like formatters or linters are, for most React projects or any like front-end projects, a no-brainer for me. Personally, formatters and linters are like super foundational tools that are so indispensable. And for me, personally, there is like no way I can work without them. So they aren't supposed to just set us like guidelines or rules for certain things. More important, in my opinion, is that they should find and fix any syntax or formatting problems in the code without any effort from us. And yeah, personally, I like to prefer the code to be deterministic. So what do I mean by that? So I'm going to show you like my favorite ESLint rule that I've only like great experience with, and that's basically anything that does auto sorting. So it's kind of like a hot take. Probably not all of us will agree with that because it somewhat enforces like a predefined grouping that might not work well with like just every use case. So this is just a small example, but imagine like a long list of a map. Maintaining groups of that can be like very, very quickly a nightmare. So deterministic code and maintainability and consistency increases basically that in the code. An example would be like, for example, like sorting anything what can be sorted without any problems automatically by the alphabet. And yeah, this way you'll get deterministic code, which makes it more reliable, predictable, and consistent, and you don't have to search for things, especially on long lists. So here's a quick linting rule that I like to use, which is called ESLint config banana. And with this, you'll get most of my like, opinionated, auto-fixable stuff here, battery included, but feel free to check it out. It's open source. And what's also worth to note is that you can enhance linting with time information, which can be very, very useful, especially when you use TypeScript, for automatically getting typing and orders in the way that you want. And this just needs like a reference in your to your tsconfig JSON, where you can see everything configured there. Two useful Prettier plugins that I have only good experience with is the Prettier plugin sort import by Trivago and Prettier plugin Tailwind CSS, in case you use that, which is super nice because they basically auto-import and sort it through your Prettier formatter. And it's just super neat. Check them out. So pretty sure they have saved me a lot of time, development effort already in the past. And you probably don't want to build interfaces inside of your app. So because oftentimes there can be components that are deeply nested inside of states until you reach them, right? And not to mention like rare or any complex states that can be barely reached. And so make sure to build components in isolation. So here are some like very, very well-established component explorers that help to build components in isolation very conveniently. So personally, I've worked with Storybook the most, as it helped me to control the states and knobs like very conveniently. And it's also a super nice tool to document and collaborate with product managers and designers, which I really love to do. So the next thing, make sure that you cover all of the different states. And what I like to do is to try to show like like all the different states at once on a component explorer. So you really want to make sure that you cover all of the different states and make sure that they sit perfectly. To help doing that, automated tests are like super available on the component level to keep the integrity of your interface and to increase the confidence of reliability, especially when adding updates to your UI code base. There is like, it's super easy like to introduce like new problems or new issues into UIs. So I know that Cypress comes now with a built-in feature to do that that helps with creating automated tests for components and yeah, for any actually various front ends or various frameworks. Now let's talk about theming. So when theming apps, there's absolutely zero cases we're designing pages or templates or, I don't know, cartoons or anything, but systems of components. So how do you do that? First, we need some kind of like attributes or values, or in other words, design tokens. The most common for the web are typography, color, and spacing. So these core values work well together to get like a truly great and unique system as a result. And in practice, applying the tokens on, for example, like a button, we represent the button in a way how it's specified in the system. So one pattern, what I totally encourage to do is to create components that dictates the layout and the spacings. So here's an example of like a typographic blocks. So you have here your header. You have like 2 paragraphs, and yeah, when you specify like the spacing between of the paragraphs, it's super common actually that to specify them on the paragraph, right? So in this case, I'm using the P plus P selector, but I've often seen also like just margin bottom on just any paragraph. And to be honest, I've only had just nightmare experience with them because they can be barely moved elsewhere without having like the correct spacing applied. So what we want to do instead is to have like a layout component, which is like the box outside. So these are more things like wrappers or containers that control the spaces between each of the child elements. So this way we can still move them out of the box and move something else in there and still have the correct gap space in place. Now, let's talk about my favorite part, building. So something worth to know is that even if we don't know, we are kind of using atomic design as a methodology for creating user interface designs. They are both modular and scalable. So think of UIs broken down into like atoms, molecules, organisms, templates, and pages, like working together to create effective interface design patterns. So it's kind of like a mental model to help us think of our user interfaces as both as like a cohesive whole and a collection of parts at the same time. So atoms in practice are typically like the smallest pieces possible. So there are things like primitives such as like buttons, inputs or selects, cards, heading, text, icon, whatever. So and then molecules are basically just compositions of atoms in its smallest fundamental units. So like this search widget, which you see here as an example. Now, grouping these molecules, you get organisms that represents like bigger sections, such as the entire top navigation bar here. And stitching more and more of organisms together, you slowly get like to create like an entire page. And so this one here basically represents one kind of a page, like, right? So it's like a template. And this page, there can be like another type of a page, which is another template, right? Now here, basically, we distinct different templates from each other, and even putting them with like real representative content. So CDD, component-driven development, is like a common like development process and strategy of building components. It's like a development strategy that anchors the build process around components. So it's a process that builds UIs from the bottom up by starting at the level of components and ending at the level of screens or pages. So in practice, the same methodology actually can be also applied on like a per component level, where you have this search input as an example, where you just create the box, and then next you think of the text value here or placeholder, and then you think of anything that decorates it, like this search icon and anything else that is like kind of like putting more granular logic into that on top of that. Now let's deep dive a little bit into code, and I'd like to show you some more super interesting that I've learned over the past years when building like UIs for mid to large projects. Basically here's how my code looks like when I totally build anything without any system, right? So it's a total mess. every time. So we need a system. So before we get deep into this, here are some super quick wins. Before we start, if we keep this in our back of our heads when building UIs, keep dump and smart or container or presentational components separated. I still, that has been like there for quite a while, and I think still applies. So it's nice to like try to keep doing that. Also, co-locate related code pods together. This means when you have like a bunch of logic inside, for example, of your React render function part, it's good if you keep like parts together that kind of belongs together. And a good way to do that is actually by building like custom hooks, if applicable. And yeah, and lastly, try to keep the API sensible and reduce the API to the surface to the bare minimum as possible. Now, let's talk about React component prop patterns. Now, this will be a little bit React focused, but I hope the most of us are working with React anyway. But I'm sure there's still a ton of stuff to pick up for any other frameworks. So let's start with the bare, Boolean prop. So here's an example of a button that specifies with some primary styles. So you'll quickly note that by specifying that as a Boolean, it will become quickly odd when you try to add another Boolean of the same kind, like here. Like, what the heck? What is that doing now? Can't do this, right? So this doesn't make any sense unless there's actually a way to do that, right? It's kind of like actually possible when you use TypeScript, when you use function overloads or typing that via union prop types. And by doing that correctly, you should be able actually to see TypeScript errors when you're using both of them simultaneously, for example, right? Right? So, yeah, alternatively, and probably my most favorite case to handle, specifically this case, is by directly specifying a prop that is a union type string literal. And so here is like a quick example of a button that uses exactly the same that as a string literal union. And in this case, a button with like a variant of button appearances. And the good thing about separating unions as a separate type, as you see here in the first line, that it can be also like very, very easily directly exported if necessary from, or imported from somewhere else. So since both are kind of like possible and technically safe to do so, here's a comparison of some key differences. So yeah, for me personally, I think that union types still has less boilerplate on the like the ones on the right-hand side with the string literal union types. So because you don't need to write like this complex union type or overloads. And it also has like better autocompletion in VS Code. So for example, if you start typing these quotes, you just see the both actual options you wanna have. Unlike here, you see like all of the, or you might see any other props that are actually possible or exposed. Now, what about dedicated components like this? Like how do these come into place now? So you have now these options, right? Basically, button primary, I think, is best when the primary prop is being used when you want to denote something primary, like the primary action of a button, such as like a form or so, where the primary button is the one that submits the form. And the button appearance primary example here, syntax, makes a lot of sense to use to change like the visual appearance of a button, such as like giving it a different color or a style, right? And the primary button syntax can be used when creating like a custom button component. This is specifically designed to always like have a button, like a primary appearance, such as like a button that is always red or is that has bold text that is like very unique, kind of like. So this can be useful when you have like a specific appearance that is needed consistently throughout a project. Now next, let's talk about enriching like a React component with types of standard HTML attributes. there's actually like a variety of ways on how to enrich like UIs with types of HTML components. So there is like button HTML attributes, component props with ref, components without ref, HTML props, HTML attributes, intrinsic elements. There's a ton. But one is like too verbose, one is too specific, and so on and so forth. So I have used actually 90% of them, and the TLDR of my experience so far is that the most accurate types you get, and the least problematic types that work for me, are any of these. So if you prefer not to be explicit if there is like a ref or not, then there is component props. But if you want to be explicit, and if you want to be like more strict about whether to use a ref or not, then you should be using like either props with ref or props without ref. And these two bottoms are actually the better recommended one and the safer ones to use. Another thing that I find important to do for building robust UIs is, let me start differently. Exposing correct types are nice, but it can be quickly a nightmare if you try to expose too many things. And these are very important, like to not expose. So it's better that you disallow this to ensure that you have like consistent styles and consistent user interfaces in your project. So by doing that, I recommend to at least like ban one of these, right? And to do that, because to do that, there is like a omit utility TypeScript function that allows you to do that by passing as a second parameter a union string type with the props. And yeah, it's great. Something that I also totally encourage to do in React components is to reuse existing types and interfaces as much as possible, or as sensible as possible. So given you use like one single component per file, I can stress enough to just reuse and export a type if necessary, so that if you add like updates to this component or to the types of the props, and anytime you import and export it, they will be just reflected automatically, and you don't have to think about on other dependencies on this prop types. And for me, it often like outweighs the work over like duplicating logics or types of that. Now here's like a quick bare minimum UI component that kind of outlines how like most of my components look like. So basically, you have the types and interface for the component props at the top. Sometimes before that, I put some variables or some static, some constants to keep like the props and the component together, grouped together. And yeah, then inside the render block, you basically have you'll find some visual logic through styles or through classes, sometimes hooks, etc. And then you keep the render function. Like you better keep it flat. So I prefer rather to do like if conditions and then render like cases when it's erroring, or render something when it's loading. But for example, if your purpose is this should render a button, then this should be like the default one, what it's rendering. And keeping it flat makes it like I think it keeps it simple, it keeps it readable. And it's nice to do so. And one other thing I want to note here also is that it's okay that you work with like third-party dependencies, like here it's CSLX for just UI components. But as soon as you start like work with, for example, Next or something like that, I think that's better. That's better placed somewhere else and not on the UI part, because when you focus on not being like framework specific, you can actually reuse that to any other frameworks, right? For example, a good example is like a link button or like a link component. Link is like is like framework specific in most cases. So to further enforce consistency of our design system in React, there's multiple strategies to render like subcomponents and that should be like themed in the same way. So I think the most important ones here are like something that is called compound components and something that is called like a polymorphic component. So compound components are basically like a group of related components that are composed together to like form like a larger and more complex component that allows like for greater flexibility and modularity. That is individual, as the individual component can be used and composed in different ways to meet the needs and the different situations. Polymorphic components, on the other hand, are components that can accept like any number of different props and render them in different ways. Like it depends on the props that are passed in, right? So this allows like for also greater flexibility on how the component is being used, as it can be customized to meet the needs of different situations by passing like in different props. I know this is like a little bit much, so don't get intrigued by the types here, but this basically showcases like a button that can be rendered as an HTML element or even like a React component here. That is, yeah, basically this is just how I like to type them in a safe way, which is super neat, I guess, because it allows me like to limit also the type by just rendering here like a button to either like just an A or a button. And yeah, basically you get the correct types suggested with using that like this. So overall, compound components and polymorphic components are both usually approaches for like building reusable components in React, and can be used like in many different situations depending on the specific needs of the project. Now let's check out generics and see how they come in handy in React. So generics in React components are like a way of specifying the types of props that a component can accept. So they are like a great way for like better type safety and better type checking in the code, which can help like to prevent errors and ensure that the component is used correctly. So basically, here is an example where I mostly often use it. So it's mostly often used for me in my case, so in forms. So the usage here, like this, isn't actually necessary, and I tried to avoid the syntax actually. But I thought it's nice to show and to know that you can do that, and that you can actually pass generic types to like a JSX element like this. Now, let's talk about overload function components in React. A great way to enforce strict and complex types in React are by leveraging overload functions components in React. So with overload functions in React components, it's basically possible to define multiple versions of a function that have a different signature or a set of parameters. This this basically allows like for greater flexibility in how the function can be used, as it accepts like different types and numbers of arguments depending on the specific needs or the situation. Now, types or interfaces in React props. This is like a pretty common debate, I would say, or on whether the other prefers this and over that. So here's my hot take. So generally, both are fine, and I actually use them both, but with a preference on interfaces. So here's why. Interfaces can extend other interfaces, which makes them slightly safer than intersection types, because it makes it impossible like to accidentally override anything, and it also allows like to enhance with additional members easily. That's useful while when you work with like third-party components, because you can just then redefine the type for example in a definition file, and then just reuse them as they are. Type, on the other hand, are more concise and easier to read than interfaces. So, and moreover, they cannot like add additional members once defined, which is both like good and bad because of the bad type safety as well here. And yeah, based from my experience in the past with like a mid to large project, I experienced actually a slightly faster TypeScript compilation in the editor by switching like hundreds of components from type to interface when possible. And on that topic, I also encourage to do to return type annotations, or to type return annotations. Type return type annotations. Especially for things like function return types. So the idea here is because it helps with like faster compilation as well, and also can help to improve the type safety and like the correctness of the code, what you expect out of like a return, right? And can make it easy to catch like and to prevent errors. Many people might not know this, but both like what I just said, like the interface and the type annotations are even documented in the official docs on the TypeScript repository. So they are basically available here under the link below. But I'll share this link. I'll share this slide, the link to this slide afterwards, so in case you miss it. Now, here are more things on TypeScript in React that I found so useful to have in the back of my head. So things like any. So that's not saying that this should be like completely disallowed, but it should be absolutely discouraged if like as much as you can, because there is like no way anything should be like really typed any unless you're lazy, and also unless they are really unknown. So think of the response of a fetch call, right? So one important way, or one way to get these types back, are doing like parsing, which is kind of like runtime checking, and then once you parse it, you get basically, or you basically checked it on runtime and get the types, correct types out of that. A nice way to do that, in my opinion, is a tool like a parser or validator called Zod, which allows me to do that. And yeah, another thing is like type assertions, or also known as typecasting, are generally considered to be bad for the following reasons. They can lead easily to runtime errors, as they don't really actually check the type of a value at runtime, and they also can make the code like very less self-documenting, as they just don't provide explicit information about the type of the value, and they can make the code like much harder to maintain and update, as they like introduce like basically inconsistencies and errors that are like not caught by the compiler. So to me, they are like more like kind of like a code smell. So to avoid these problems, it's generally better to use type safe techniques such as like type guards or type checking functions, and have correct types at runtime after that. And this can help prevent errors and ensure that the code behaves as expected. So the same thing with non-null assertion with the exclamation mark at the end. Better use type guards or type checking functions so that you can ensure that the types are correct at runtime and prevent errors so that the code behaves as expected. So with all that being said now, I think it narrows down to definitely not forget about setting this to your TS config, strict to true. And apart from that, there is a bunch of other super helpful other flags that are actually not included in the strict flag, but hopefully they are in the future. So to name a few, there is like allow unreachable code, allow unused labels. My favorite one is actually the one over here, no unchecked indexed access to true. This basically is when you have, for example, like a list of numbers, or expecting like a list of numbers somewhere, and then you access like the first one. By default, you get basically just a number, which is in most cases not correct, because sometimes it can be also just something nothing, because the list is empty, right? So yeah, now all that being said, it's helpful to keep those things in mind when building robust and resilient UI components. So those are the things that truly help me to build and keep consistency, stability, and type safety of UI components. And overall also like a peace of mind. Now here are some takeaways before I'm about to finish my talk. So proper setup of toolings, such as like linters, compilers, and testing frameworks, definitely help to increase the developer experience and therefore help to write high quality and robust code. A resilient design system provides a set of standardized, well-defined components that can be easily integrated and reused throughout the code base, encouraging like the creation of robust code. Strict types help to ensure that the data in the code is valid and conforms to a specific schema, making the code like more predictable and reliable and encouraging the creation also of robust code. Strict types also encourage the creation of robust codes by providing a clear, well-defined interface that ensures that the data used there is valid and consistent. And the key of creating robust is basically simplicity. So as simple components are easier to understand, maintain, and reuse, and are like less likely to contain errors or cause problems in the user interface. And they are also like very, very much more readable than any other. And last, or the one before last, UI components should be reusable to allow easy integration into different parts of the user interface or even outside of your application. And to reduce the need for recreating similar components, it saves time and improves the code quality. Lastly, take good care from the ground up. Ensure that the code and user interface is well designed and maintainable from the beginning, preventing like issues and any bugs arising in the future. That's all I got. Thank you very much.